So here is a display cabinet, which you can see is rather gaudily lit by Neopixels. This is just a demonstration feature. My taste isn't that bad that I would have a flashing disco in my house, but it shows you how things work. So how this is put together. Really the hardest part, as I was saying on earlier videos and comments, is gluing the Neopixel strip in place. It was very difficult. I tried blue tack and various other things. In the end, I went with hot glue, which you can just see on the edges there, and masking tape, and we'll probably use some more glue. And then ran a wire down here, so we've got 3 wires. We've got basically positive, negative, and a signal wire. And so you can see the power's coming in here. So I've just got a bench PSU underneath there. Probably come up with a more permanent solution eventually when I've got this working. Here's my Arduino running the program, written in Swift for Arduino, of course. This is power coming into the Arduino, power going into the power strip, so that's to the Neopixel strip, and then this is the signal wire here going to the Neopixel strip from the Arduino. And now we'll just cut and show you the code. It's really, I think, really quite straightforward. None of this should be too unfamiliar to any of you who have worked in Swift for any length of time. So first thing we do is set up the pin where we're sending the signal out. So I've created a constant here, iLED pin, just to make it simpler, and set that to pin 8, whichever one you're using on your Arduino. And then this is quite important for the pixel library that comes inside Swift for Arduino. You have a constant, or you have to specify the number of pixels, and then essentially how it will work in the standard Neopixel, you do a setup, so we'll go over the setup call in a minute, and then each time you want to set things, you set a pixel color, and they kind of push along, and then the minute you stop for more than something like 6 microseconds, stop pushing pixels, then it will latch the values that you've sent. So it's a little bit of a strange concept, but this is how they managed to make it work with a one-wire protocol. It's pretty fast and efficient system. And if you look at the wires themselves, they're all daisy chained together. Each LED, they're not super cheap, but each one's got built-in RGB and sometimes white LEDs, and can consume quite a bit of power in the end if you've got a lot of them. And each one daisy chains into the other, and that's how they work. So basically, if it gets a new value pushed in before it latches, then it passes that value on to the next one in the chain, and so on. And then if you wait a period of time, then it just latches with the last value it was given. So fairly simple protocol. That's more or less how it works. In Swift for Arduino, you've really just got a few important calls that you do, and you can see these here, here, and here. So the first thing you're going to need to do is do a setup where you say how many, say which pin you're using, how many pixels on that, and then a couple of values that will depend on your particular types of Neopixels. So the ones that I've got here in this 60 pixel strip that you saw that I'd glued up in my display cabinet are the slightly more expensive and larger type that have a white LED built into them. It can give you a much stronger washout of white if you get those. They aren't strictly necessary though, really. If you've got the RGB only, then you can turn on obviously all 3 RGBs at their maximum value of 255, and that will give you a white, really a passable white. But some people like to I got the slightly more expensive strip for this particular one. And then you've got this next flag, which is GRB ordered. So this is essentially which order the bits for each of the RGB values are sent down the wire. So the way it works, when you send a value for a pixel, you essentially just send 3 or 4 bytes down the wire, and the normal arrangement is you send the green and then the red, then the blue, and then the white last of all, if there is a white. And I don't know why historically that's just how it is. There are some rare chips where it's RGB ordered, but you should know that from your sheet, and generally speaking for almost all of you it'll be GRB ordered, so you can almost always leave this true. I nearly defaulted this parameter, but it just adds a little bit of a delay into the API. And then here is a 6 microsecond delay. So this is the latching delay. So in iLED fast setup, you'll have a little bit of kind of configuration, and you can turn off the pixels if you want. Next, we've got a constant here, which is, I'm going to do steps on the color. So what I want to do is, you can see, if you notice, there was a nice fade in and fade out. And the way we do that is we're basically turning the color on gradually, going from black onto full color. And we'll go into the how the color's made in a minute. It's using the HSV model. But essentially, it's how do we change the value from a value of 0 to 100? How long do we wait? How many milliseconds do we wait between each step of it? So we've got a constant here, and you'll see that in a minute when I describe this function, which is the body of the function, really. And it's from here, it's really straightforward. Okay, so let's break into the functions now. There's 3 main functions that kind of give you most of the behavior of this. So the first thing that I mentioned a minute ago, when we're doing this, when we're making, when we're driving NeoPixels, you need to do the setup first, and then for each frame, in a way that you want to do, each set of pixel colors, you need to push down 60 values if you've got 60 on your strip, or 10 values if you've got 10 on your strip. Otherwise, you'll leave things unambiguous. If you've got a 60 pixel strip and you only push down 30 values, then you'll only fill up half the strip with the values that you want, and the last half could be doing random things. It could have the values that it used to have. It might not even behave like predictably. That said, what we're doing here, we're doing the full 60, so you can see a loop down here. We'll get to that in a second. The first thing we want to do is make a color. So the purpose of this function is to say, I want to change all 60 of the NeoPixels on my strip to show one color. And that color is going to have a hue, saturation, and value. And this function just takes in a hue and a value, and we'll see why a little bit later on. And then passes them in with a saturation of 255, full saturation, so not washed out in white at all. And we're setting the white pixel to 0 for this program. And here's the body of it that I was talking about with the NeoPixels. So basically, we start a variable. Now, some of you will be a bit unfamiliar with this if you haven't used Swift for Arduino before. This is a critical thing that you need to learn how to do. Unfortunately, for loops don't always behave predictably in Swift for Arduino because Swift puts in a load of code underneath it that can make it inefficient, but more importantly, can cause aborts and things like that because it uses non-wrapping arithmetic. So what we do is we write our own version. We basically make our own for loop, like an old-fashioned one, just using a while loop. So what we're trying to do here is we're going to say start from 1 to the number of pixels we've got, which is our constant we set up here. So 1 to 60. Fast write pixel, this is the core function of the NeoPixel support that's built into Swift for Arduino. And all it does is you've got a color that's defined. We've got some constants like red, green, blue. But here we've just made a color a minute ago with the hue, saturation, value that we specified. It writes that, and this needs to be done quite quickly. So this while loop, there can't be significant delays in here because otherwise the latching will start to interrupt with it. So you need to kind of push these pixels down as fast as you can. And so what we're doing basically is we're passing the same color value down. So incidentally, if you kind of make a different color value each time within here, then that could slow it down a little bit. So you kind of you might need to plan ahead a little bit on that, and you might need to find experiments. And here, if you haven't done Swift for Arduino before, this is a critical factor again. So we're incrementing I by 1, but this operator is really important. So we don't just do I equals I plus 1, because that can create abort situations in Swift due to integer overflow. We do this version, which is basically wraps if you accidentally overflow. Now, there should be no reason why we should overflow a uint 16, because that's 65535 would be the maximum value on that, and we're only going up to 60. But this is how you always do arithmetic in Swift for Arduino. And this means that you can't get an abort situation, which is of no use in a microcontroller. Okay, so basically that's just pushing down 60 values down the wire, and that will then after a short delay, even a 6 microsecond delay would be enough, but here we're doing a 1 millisecond delay. That will latch all of those values and they'll come up on the NeoPixel. So this will basically just light up the whole strip with one hue and value. Now you can kind of see how these functions are going to work. So basically your value is going from 0 to 100. You're showing that across the strip and then you're incrementing, or you're going from 100 down to 0, showing that across the strip. So now we've got two functions for fading in using a particular hue or fading out using a particular hue. And here's our little sequence. Fade in, wait 200 milliseconds, and then fade out with the same colors. And finally, we can see this is the endless loop, which is the traditional thing that you're always going to get in a microcontroller. And it's showing 4 different hues: fade in, wait, fade out, fade in, wait, fade out, fade in, wait. And that's how you get the 4 different colors. And that's basically it. So please write comments, join us on our Slack channel, download the free version or buy it today. It's only $20 right now, and you're going to have so much fun if you get this and have a play. And make comments, join in, get involved in the discussion. Okay, thank you.